This system of linear equation is going to be a bit tedious, so let's use computer algebra system. Let's clear some variables here, and then y1 is defined as e to the t power cosine of 2t. y2 is defined as e to the t power sine of 2t. Okay, and let's find out. So v1 expression v1 that replace u1 prime, and then y1 t plus v2 y2 prime of t is equal to e to the t power. There goes one equation. And the second equation, v1 y1 of t plus v2 y2 of t is equal to 0. And let's solve this with respect to expressions v1 and v2. And it's just brute force computation, system of linear equations. Some derivative computation, of course, is necessary because y1 prime, y2 prime, using product and chain rule, you can do all those. So assuming you did all those, you got v1 and v2 like this, which means u1 prime, the derivative is negative sine of t over 2 cosine of 2t squared plus sine of 2t Wait a minute. This is cosine squared plus sine squared, so that should be 1. The reason Mathematica is not simplifying is because in complex number system it's not always 1. So I can just write it like this. Negative 1/2 sine of t u2 prime is 1/2 cosine of 2t and we have both of those. Now if you take the antiderivatives, then you're going to get your 1 as antiderivative, so negative 1/4, and this is going to be cosine. And taking the antiderivative, you get 1/4, and this is going to be sine. Therefore, particular solution is going to be u1 y1, so u1 y1 plus u2 y2 is going to be 1/4 cosine of 2t u1, and then y1 e to the t power times cosine of 2t plus 1/4 sine of 2t and e to the t power sine of 2t, and looks like that is the particular solution. Oh boy, rather complicated. And this is, oh, wait a minute. This can be simplified a lot. We get 1/4 e to the t power and cosine squared of 2t plus sine squared of 2t. That's 1, isn't it? So this whole thing is 1/4 e to the t power. And that is the particular solution. And the end result became so simple that I'm pretty confident this is the correct answer. 1/4 e to the t power. Let's check that. And then let's simplify the differential equation here. Minus 2y prime of t plus 5y of t. And simplify. Am I going to get e to the t power? Yes, indeed, we got it. So this is the correct particular solution. Well, we got it, so let's go ahead with the final solution or final answer here. Is C. Did I use A and B or C1 and C2 previously? I used A and B, so let's stick to A and B. A e to the t power cosine of 2t plus B e to the t power sine of 2t plus 1/4 of e to the t power should be the general solution. Let's check. Is equal to A. Oh, excuse me, let's clear A and B as well. So A e to the t power cosine of 2t plus B e to the t power sine of 2t plus 1/4 e to the t power. And let's put this into the differential equation. Simplify. What is this? Why am I not getting the answer here? Did I miss something? Oops, here. E to the t power, but I ended up writing second power. Okay, that makes perfect sense. E to the t power, I have it. Also, let's check again. Desolve 2y prime of t plus 5y of t is equal to e to the t power, and solve it with respect to y of t with independent variable t and excuse me. I have to clear the variables. Okay, what do you have? Is that the same solution I got? I guess so. It's the same solution. And I have something here, but that's okay. That's gonna be absorbed by 1/4 e to the t power, and some additional part will be absorbed by arbitrary constants. So no big deal there. This is okay. So that verifies everything.